Okay, so let's do this truss today.
Also, there wasn't any homework given for Wednesday.
No.
Okay.
So we're not like doing anything. We're just. It's not worthy of my notebook.
Ooh.
Yeah, I probably should have split it up on one instead of paper.
Yeah, I've got my cheap notebook for homework and examples, and my fancy one for notes.
That's funny. That's an elaborate system.
The notebook was $12, so I'm like kind of, but it's like it's just
I
like.
do that for calc. I have one notebook I bring to class and another one I only do my homework.
Uh-huh.
I get these legal pads for free from work.
Oh, where do you work?
I work at like a civil engineering consulting firm, so they just have like a big room full of paper and pencils.
Okay, so let's do this. And all these angles are 20 degrees. And let's make all the lengths 1 meter. That can't be 1 meter, can it? So I guess we'll make these diagonal ones 1 meter. And then the horizontal ones then have to be 1.88 meters, I think. Okay, and we'll name these. So there's 1, 2, 3, 4, 5, 6, 7. And for the joints, we'll go A, B, C, D, E. All right, and if we were going to just do this with the full method that we use for everything, how many variables would we have here? Yeah. 21, yeah. Right. 7 times 3. So this is pretty similar to the one we were doing that we didn't finish. So 21. Doing this as a truss, how many variables? So let me write that down.
Do we need to do one for A? Like a free. Like, because before
Yeah.
we just did the one in the middle, so would it just be B, C, and D?
Well, I don't know yet. But I do know how many variables we're going to have, so we have to come up with that many equations. So how many variables are we going to have?
7.
Perfect. Yep, 7. So that's a big improvement, especially if you're going to do this by hand. And so, okay, at each joint, how many equations do we get? 2, right? Because we're just using Newton's second law for each pin. Okay, so let's see. We have 1, 2, 3, 4, 5 pins. We need to solve for 7 variables, and so we don't need every one of these pins. It looks like we can skip one. So we'll figure out which ones to neglect once we get going. But let's start by doing. So we'll do this as a truss, and let's start by isolating the pin at B, and we'll just keep going from there. So take a couple minutes and see if you can come up with Newton's second law for the pin at B. So our first three equations, we have F4 plus 0.940 F3 minus 0.940 F1 is equal to negative 5,000. Maybe I should have done these as vector equations first, but, and then the second equation says negative 0.342 F1 minus 0.342 F3 is equal to 0. So, I mean, I just got those by doing, so we have 5,000 0 plus F4 0 plus 0.940 F3 negative 0.342 F3 plus negative 0.940 F1 negative 0.342 F1 is equal to zeros. And then just put it into that equation. Those equations. Okay, so now let's do C. For this one, we have F2 this way, F3 this way, F5, and F6. Everyone good on that free body diagram? And then Newton's second law says negative 0.940 F3, positive 0.342 F3, plus negative F2 0, plus 0.940 F5, 0.342 F5, plus F6 0 is equal to zeros. Everyone get the same vector equations? And so our equation, we have two so far, so our equation 3 says negative 0.940 F3 minus F2 plus 0.940 F5 plus F6 is equal to 0. And our equation 4 says 0.342 F3 plus 0.342 F5 is equal to 0. And now let's go to D. So for D, we have F4 that way, F5 that way, F7 that way, and then the 3,000 down. So Newton's second law in vector form says negative F4, 0 plus negative 0.940 F5, negative 0.342 F5, plus positive 0.940 F7, minus 0.342 F7, and then plus 0, negative 3,000. Is equal to zeros. And so our equation 5 says negative F4 minus 0.940 F5 plus 0.940 F7 is equal to 0. And equation 6 says negative 0.342 F5 minus 0.342 F7 is equal to positive 3,000. Okay, so I wanted to get, I wanted to make sure that I had all 7 variables in my equations. So we have F1, F2, F3, F4, 5, 6, 7. So that's good. We have 6 equations so far, so we need another equation. We could isolate A or E. Those are the 2 we haven't done so far. Let's go E.
So if you were to do A, you would, like, the roller just doesn't even matter. Or you're just kind of
right.
assuming, like, I guess it just doesn't matter what's going on over there because you know what's happening with 6 and 7.
Yeah, I mean, the fact that it all has to be in equilibrium kind of specifies what you have to have happening over here, I guess. Yeah, I don't know what would happen if we isolated A. Let's try it. Let's see what happens if we isolate A. So what can happen is that you can get cases where you have your 7 equations, but one of them is a linear multiple of other equations you have, and then you just need to use a different equation. That can happen. Let's try A and see if that happens. So, okay, so for A, we have the two members attached to it, and we also have the reaction force from the ground. So I'll call that RA. So we have F1, F2, and then a force vector from the pin joint that I'll call RA. So the equations say RAX, RAY plus 0.940 F1, 0.342 F1 plus F2, 0 is equal to zeros. And so our equation 7 says RAX plus 0.940 F1 plus F2 is equal to 0. Equation 8 says RAY plus 0.342 F1 is equal to 0. Oh, so now that's why we should have chosen the other joint, because we just introduced 2 new variables. Okay, so now we got to keep going, Well, now we know.
Just ignore this one and do E?
Yeah, bless you. So pretend we didn't do that.
Good thought experiment.
Yeah. And do free body diagram for E instead. For E, all right, so we got, what's that, F7 and F6, and then RE like this. And so Newton's second law says negative 0.940 F7, positive 0.342 F7, plus negative F6, 0, plus 0 RE is equal to zeros. And so equation 7 says negative 0.940 F7 minus F6 is equal to 0. Equation 8 says 0.342 F7 plus RE is equal to 0. And now we have 8 equations for 8 variables. So could everyone take a second and solve this, and let's see if whose answers match. I got, tell me what you think of these. Negative 3, 4, 4, 2. Huh?
Nope.
Oh! Anybody?
745.54.
Negative 863.
Negative 863.
Ooh.
Yep.
Okay, let's go with that. So negative 8 for F1, it's negative 863.
195. Yep.
And F2,
5811.
0.11? Or,
Yeah.
5811.4.
5811.4.
okay. F3,
863.2.
okay.
Negative 6622.8.
66 what?
22.8.
Okay. F5,
Negative 863.2.
okay.
7434.2.
434, okay.
Minus 7809.7.
Okay.
And 2704.8.
2704.805, let's see. Okay, so, well, you wouldn't, I don't think, look at this and necessarily be able to figure out which of these members were in the most danger of breaking, but, now this tells us something important about that. It turns out that member 7, I guess, is in real bad shape.
4.
And notice that the negatives tell you the member is in compression and positives tell you it's in tension. So this member 7 is in a lot of compression. That member 6 is in a lot of tension. And so on. So, yeah. Any questions about that?
That felt like magic after how long it took to do that other one.
Yeah, exactly. I mean, yeah, if you have the right problem, it can save you obviously like a ton of time, But it doesn't take much for it to go from being the right problem to not being solvable by this method. Okay, well,